mute too, just by the way.
Thank you.
Yeah.
Hi, everyone. I'm Dion Whitehead. I'm a fellow at the Astera Institute. Got a one-year grant to improve, well, part of the program to improve tools for open science. I've been a scientist and then have been working in industry on games and then tools for scientists, and that's my major passion, is really helping scientists. So here's an example of a sort of quasi-typical sort of workflow of a PhD student. So what we have here, a bunch of tools cobbled together, versioning, guides, but so much friction was involved in this. 30 to 40% of it was just low-level debugging, things like linking third-party libraries in the operating system. And for many of us in this space, you want to use the latest tools, and there's just so much friction involved in putting these tools together, getting them working, and this is part of the reason why interoperability and using tools can be really difficult. It's a recent example for myself. I wanted to use this visualization, and then I just hit some compile issue deep in the weeds of a third-party tool. This is not anyone's particular fault. This is just the nature of a lot of scientific software. It works in one place, it doesn't work in another place. Things change, versions change, and this, I don't have the time in this particular case to sort of debug this and sort of using this kind of ends. It's not a criticism of this particular tool. This is just an example of many tools. So, here's another example. I want to use this dash visualization, and I just hit there's some issue involved in version somewhere. So the point is not, can I debug this? It's, do I have the time and the skills in this particular case to do it? So there's just a lot of tools, and there's a lot of things that change behind the scenes, and all of this becomes friction, right? Like just finding things, downloading tools, versions, host requirements. Do I have to compile this tool? A complex GPU integration, and then integrating it into my workflow. So there's just so much friction involved that it becomes, it's not the only part of reproducibility. There's lots of structural things about reproducibility, but one part definitely in reproducibility is just the time that it takes to reproduce things, even if they are purely computational. So what are some of the tools people use? So we've got Jupyter notebooks, embedded in Google Colab has their own one. So what's kind of good about Jupyter notebooks? We've got visualization, you've got this sort of notes with it. But part of the problem with Jupyter notebooks is you've got this sort of compute kernel tied to this kind of blob of text and code all mixed together. And that compute kernel makes it kind of difficult to share in a lot of cases. And Google Colab's made it a little bit easier, but then you're tied into their particular system. So they sort of make one step of sort of sharing and interoperability, but it ends up being somewhat unsatisfactory and difficult for lots of sort of different reasons. There's a lot of people using sort of back-end workflow tools like Nextflow and SnakeMake and things like that. So you sort of write some DSL or YAML or something like that to define your steps, and then the workflow manager sort of takes that and runs it on the back end and runs that. But that's a purely sort of back end processes. So with a lot of these tools, notebooks and workflow managers, they're hard to sort of interoperate. The formats are different. They don't really easily work well together. There's a lot of friction there. And they're not really have the sort of composability that I sort of want to use with my tools, like the sort of Jupyter notebook thing. It's kind of one thing. You can kind of take things out, but not easily and not naturally. And the sort of components in these back-end workflows are sort of interoperable, but there's a lot of gotchas, especially around that. So what's the ideal? Well, what's kind of my ideal is I see a paper and it's in the field that I'm in. I'm like, that looks awesome. Um, so rather than just having a paper, the paper comes with a workflow that's just in the browser. And I just click a link. And now I'm directly able to interact with it in a way that's meaningful. And then I'm like, wow, this is going to be pretty useful. I like the shiny thing that they did. So I have my workflow also in the browser, and I want that I want that fancy simulation because I'm doing something similar. So I'm just going to actually literally just grab it and move it over. And that's what I want. There's this sort of missing part in science that's this sort of fun exploratory part that's hindered by a lot of the sort of friction and pain involved in sort of reproducing these computational elements and combining them together into sort of workflows that can be shared. So I want to easily find things, and I just want to bring them into my workflows and just have them work. And then once I've done that, publish that for anyone to then use. So I'm going to show you a live demo, but part of the core concepts is that everything's a URL. So the workflow that's in the browser, which I call the meta page, it's a URL. And all of the individual components are also websites. So you can basically embed anything that can be represented by a website in these workflows. And so one of the sort of parts that make this easier for the computational parts to move around is I have abstracted the API for running container compute. So I have an API, and you have a component in there that's going to run some kind of Docker container. It goes on the queue, and then it's kind of like Circle CI or GitHub Actions if you're familiar with those. You have a Kubernetes cluster or a Slurm or your own laptop or your own lab workstation. I'm going to make it really easy for you to bring any of those and just point those compute resources at this queue, and it will just then take that work off and run it. And so then now anyone can run your workflows just using their laptop if it has enough power, or on their own infrastructure, just running Docker containers. And because these are URLs, you can embed them. You can easily put them in blogs, put them in Notion. You can click on them in social media, and when you click on them, or when they're in Notion or a blog, you're getting a workflow that you can interact with live in that medium. So I'm going to jump to a live demo. So this is the website at Metapage.io. Sort of an open beta right now. You can join. Where are we here? So let's go look at some of these ones. So here's an example of, so I took this demo off the Dash demo to adapt it. But basically what we have here is we have some input data, CSV. So you've got files, and I'm running a Docker container here. So it's doing its thing. Where is it running this Docker container? It doesn't matter, or it does. So I'll take care of that, or it's important to you, and then you're going to run this on your infrastructure because it's important to you. And then I have a visualization that I can click on and interact with it. And so all of the components here are all individual decouplable components. This one here only runs Plotly in this case. This one only runs the Docker container. So I can take any part of these and mix and match them with any other part and replace them. And I can go in, and these are all editable. So I can go in here, and I can go in here, and I'm going to be editing the code for code. It takes a little while to load, and I can just edit the code directly. So if I give this to you, or you go to this link and you copy it, you've got all the code to run this. Here's another simple little workflow where I take some species and then I grab some. I want to make a phylogenetic tree. So I have a little script that grabs the sequences. Some error there. This container runs multiple sequence alignment. I generate the tree. And then I missed one of the species there, so normally there's an extra one there. And then I have the JavaScript. So all of these things again, interoperable, composable with data flow and embeddable. So if I go to dun, 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 let's look at a meta page. Oh, okay, something happened there, but let me just try this one anyway. Let me go to another one. So here's another example of, so what I've done here is I've got a gene network simulator. So someone published a paper, and I took the Git repo, I put it in a Docker container. So I can just do this here. So I can just create a Docker container. So I don't know these people who did this. I should reach out, but I don't need to know them. They published it. It's got their Docker repo. I build it. I run the simulation, and I get some results here. And what I've done is I've attached a little slider here. And what this does is this modifies this value here. So I have a little JavaScript slider here. Once I modify it, it reruns the simulation and I get the updated results and the internet connection is slow, so it's taking a little while to reload that. It says, oh, there we go. And the results are cached. So what I've created here is a high-level resolver for a simulation. I've allowed you to just send this link to the people on your team, and they can, in a human way, turn a dial and see what happens if I change this variable. And everyone can now interact with this complex simulation in a simple way. And this is all reproducible, but they can also just go in and modify, the code that defines the model themselves if they want to. So you have full access to everything in an easy way, but you can also pop it open and peer under the hood and change any of the parameters. What's another demo? Jupyter Matplotlib. What's this one doing? Let me go back to the main demos here. Molecular. So this is just a simple one that just downloads a PDB, but you can attach this to any of these workflows to show molecules. So if anyone wants to sort of add some advanced visualization tools to anything they're doing, please reach out. I would love to talk to you. What else we got here? You are not limited by any, no, well, not that one. Back, maybe the links from using your front-end visualization. Nope. So I've got search as used type, front visualization. So you're not limited to any front-end visualization library. You can use any of them or all of them. They're all interoperable. So here I've got the data set and I've got different front-end visualizations. So this is all, any of the front-end visualizations you want to use, and you as a user can just use any part of them. I can take any of these and I can sort of add them to the global library here, and now anyone now can instantly use that visualization component or set of components. And how am I doing for time?
We can head into questions, Dion, if that's okay.
Yeah.
Cool.